Okay, Matthew, I figured it out, and I want to talk you through the solution to this last one that we were working on. So we're trying to solve for A. We've got A's on both sides of our equal sign. And so the first step I took, I still like. So we're going to add 2A to both sides, and we get the absolute value of A plus 3 plus that 2A must equal 12. Now we've got to think about the fact that if A plus 3 is greater than or equal to 0, this is definitely a tricky one. If A plus 3 is greater than or equal to 0, then that means that when you take the absolute value of that quantity, it's going to come out to be a positive number or equal to 0. So I'm going to take it out from underneath that quantity, and now I'm going to solve for A here. So when I combine my 1A with my 2A, I get 3A. So I've got 3A plus 3 is equal to 12. Someone at Domino's made excellent pizza. So I've got to undo the addition by subtracting 3 from both sides. And I get 3A is equal to 9. And then I have to undo the multiplication by dividing. And I told you by graphing on my calculator, I knew there's a solution at A is equal to 3. Now here's the tricky part. We also know that A plus 3 could be a number less than 0. But when you take its absolute value, then it produces a positive answer. So what we have to do, if A plus 3 is less than 0, then that means when we take it out from underneath the absolute value brackets, the absolute value is going to make us drop the negative sign. And therefore, because it's going to do that, the A plus 3 would actually have the opposite value of what the absolute value would give us. I hope that makes sense. So because when you take the absolute value, it drops the negative sign. If A plus 3 is a negative number, then that means that when we drop the negative sign and take its absolute value, that means that A plus 3 must have been the opposite of that. Again, this is a very tricky one. So now I'm taking the opposite of A plus 3, and I'm going to add 2A, which is just writing the rest of the equation down, is equal to 12. And now I'm going to solve for A here. So that negative out in front is like having a -1. We need to distribute that to both the A and the 3. So we'll have negative A and negative 3 plus 2A is equal to 12. So combine like terms, negative 1A and positive 2A make up A. So I have A minus 3 is 12. And then finally, you'd have to add 3 to both sides. And you get A is equal to 15. Now check it out. We knew that 3 was going to work, but look what happens if A is 15. Then I would get 15 plus 3 in the absolute value brackets. That's 18. So the left-hand side would come out equal to 18. If I plug in 15 here, I'd have 2 times 15 is 30, and 12 minus 30 is equal to negative 18. Our left-hand side came out equal to positive 18, and our right-hand side came out equal to negative 18. Those are not equal. Therefore, A cannot equal 15. It is not a solution. Our only solution is if that quantity inside the brackets, A plus 3, produced a number equal to 0 or greater than 0. Then, in this case, it would be greater. It'd be 6. Then if A were 3, the left-hand side comes out equal to the right-hand side. That is our only solution. Let me know if you've got questions.